Now we're starting the lesson. Okay, in this lesson, I will solve past paper questions about Kirchhoff's law. Look at question number 1 in front of you. So the first step, we use junction. Point C is a junction, and also point F is a junction. That are only the two junctions in the circuit. Now, follow the currents. I1 start at the junction F, so this is the direction of I1. This is the direction of the current I1. This is I1. And end at junction C. This is I1. I3 start at C and end at junction F. I2 start here from junction F. So this is I2, which is given. I2. I2. So this is very important point. Now, in part A, we use one junction. Let us, we use junction C. So we write at junction C. Kirchhoff's first law states that at any junction in the circuit, the sum of currents in equals the sum of current out. The current in is I1. It depends on the arrow. The current in also I2. So I1 plus I2. The current out is I3. Of course, not all the currents will be in or out. So some of currents must be in and some of currents must be out. Already I2 is given 0.6. Then we write I1 plus 0.6 equals I3. Let this equation number 1. Now we use the loop. Here we have 3 loops in the circuit. This is loop number 1. How can I choose loop number 1? According to the direction of the current in the circuit. You can see the current go in this loop. Second, we have to put the direction of electron flow. The direction of electron flow, this one. It's from negative to positive. This is the direction of electron flow. It is separate to the direction of current in the loop. Now the current in the loop 1, it's given here, it's anticlockwise. We start from any corner and follow the direction. Then we start from this corner. Now, follow me. I say loop 1. When I say loop 1, it means we apply Kirchhoff's second law. Remember, the resistor, the potential difference across the resistor is negative, and the EMF, it depends on the direction of electron flow. I go in this direction. Can you see this is the direction of the loop? The current is I1, and the resistor is 1. So it's a negative 1 I1. Here, the direction of the loop, the same direction as electron flow. So it's plus 12. And then nothing here. And then I go in this loop. The current is I3 and the resistor is 3. And the direction of the current is the same direction as the loop. So it's 1 negative. Negative 3 I3. Still, here, the current is I1 in the same direction of the loop, and the resistor is 5, so it's 1 negative. Negative 5 I1 equals 0. We simplify the equation. So negative 1 I1 and negative 5, it's negative 6 I1. Minus 3 I3. We shift 12 to the other side, it will be negative 12. Simplify the equation as you can. So we can divide by negative 3. Divide by negative 3. Then this equation in simplest form becomes what? Becomes 2 I1 plus I3, negative 12 divided by negative 3, it's 4. Then this equation number 2. Okay? Now, here in equation 1, we have the value of I3 in terms of I1. Then we substitute from equation 1 in equation 2. So we write this from equation 1 in equation 2. What do we do? Just we replace I3 here, I3, by its value. Its value is I1 plus 0.6. Then you will get 2I1. Replace I3 by its value in terms of I1, which is I1 plus 0.6 equals 4. Simplify. 2I1 plus I1 is 3I1. So 3I1 equals. Shift 0.6 to the other side. 4 minus 0.6, it is 3.4. Divide both sides by 3 to get the value of I1. So divide by 3, divide by 3. Then we can get the value of I1. So I1 equals 1.13 ampere. This is approximation value of I1. We can get I3. Substitute in equation 1. So substitute in equation 1. So 1.13 plus 0.6 equals I3. Then I3 from this equation equals 1.73 ampere. So this is the value of I3. So now we finished part A. Calculate the values of I1 and I3. Now try to solve part B. Find the value of electromotive force. I advise you to choose this loop. Then use this loop, please, to solve. Start. Part B, we said that loop 2. Now, let us see part B. So we write loop 2. We start with junction. So we start with the junction E. And sorry, we start with the point E, not junction. E is not junction. And then we go through this loop. The resistor is 1 and the current is I2, and it is in the same direction of the loop. Then it's 1 negative. So negative 1 I2. Here, the electron flow is the same direction at the loop, so it's a plus EMF. And then the current is I2 and the resistor is 5. It is the same direction of the loop, so it is 1 negative 5 I2. And then here, the current is I3 and the resistor is 3, and the current is the same direction as the loop, so it's 1 negative, so negative 3 I3. Finish. Equals 0. Now we do substitution. First, we simplify. Negative 1 I2 and the negative 5 I2, it's negative 6 I2. Okay, plus electromotive force minus 3 I3 equals 0. Already we got I1 and I3. Okay, but what about I2? We can get I2 from equation 1. No, I2 is given. I2 is 0.6. Then negative 6 multiply I2, which is 0.6, plus electromotive force minus 3 multiply I3, we got it before, 1.73 equals 0. Now use your calculator to calculate the number. Negative 6 multiply 0.6 minus 3 multiply 1.73. So the answer is negative 8.79. So E minus 8.79 equals 0. Shift negative 8.79 to the other side, then the electromotive force is 8.79, the unit is. Okay, guys? Do you have any doubt? It's okay? Now, next question. Ready? The figure below shows an electric circuit. Calculate I1 and I2. Can I start to solve? Okay, follow me, please. What is the first step? Of course, the junctions. We have here two junctions in the circuit. Junction F and C are only the two junctions. They are the points of connection of the wires. The three wires are connected at F and C. A, B, D, and E are not junctions. Now, second step, we follow the direction of the current in the circuit. I1 start from junction C. So this is I1. This is I1. Can you see? And end at junction F. So this is I1. I2 start at F and end at junction C. I3 start at F, I3, and end at C. So all the currents start at junction and end at the other junction. Now, we say at junction F. At junction F. We have to put the direction of electron flow. The direction of electron flow, it's separate to the direction of the loop. So this is the direction of electron flow. This is the direction of electron flow. But the junction, it is Kirchhoff first law. But just we put this here. Now, at junction F, the current in is I1. Only I1 is current. The currents out are I2 and I3. So I1 equals I2 plus I3. This equation number 1. Here we have 3 unknowns. Then we need 3 equations. Try to, this is a practice for you. Yes, I think he will not come. This one, I think it will not come in the semester exam, because just it came in the re-exam. Because in the syllabus, just 2 simultaneous equations. But in this question, we need to form 3 simultaneous equations. But I solve with you, don't worry. Now, we take the loop. What is the direction of the loop? When you have 2 EMF, look at the big one, the 6 volt. Then take the direction, this 6 volt, and the down, it's 4 volt. Then the direction from higher voltage to lower voltage. Then this is better to take, this is the direction of loop 1. Why? Because 6 volt, can you see? It's more than 4 volt. Then the current goes from higher voltage to lower voltage power supply. Then this is loop 1. Then we write loop 1. We start from corner like B and then go and follow the direction of the loop. If the current, the same direction as the loop, it's 1 negative. Then it's 1 negative. So the resistor is 1 and the current is I1, so it's negative 1 I1. Now, electron flow, it is the same direction as loop 1, so it is plus 6. And now here, now down, the direction of the loop is opposite to direction of electron flow. Then it's negative 4. The direction of the current I2, the same direction of the loop, so it's 1 negative. The resistor is 1 and the current is I2, so it's negative 1 I2. Finished, equals 0. Simplify. So negative I1 minus I2, 6 minus 4 equals 2. To the other side, it will be negative. Simplify, it's better to change the negative, divide by negative 1. Then we can say I1 plus I2 equals negative, no, it's positive 2. Then this equation number 2. Okay. Okay, loop, okay, 2. We can take this direction of loop 2. Now, loop 2. This is the direction of the loop. Then we can start from the corner F. Now, the current is I3 and the resistor is 5. So it's 1 negative. So negative 5 I3. Then here, now, the direction of the loop is opposite to the direction of the current I2. Opposite means negative. Then we add more negative. Because what? Because the current I2 is in opposite direction of the loop. Now, the resistor is 1 and the current is I2. So it's a negative 1 I2. Why I put 2 negatives? Because the current direction is opposite to the loop direction. Opposite in physics means minus. Now, EMF is 4. The electron flow, it is the same direction of the loop, so it's plus 4. We reach to the point F, then the answer equals 0. Now, negative 5 I3, negative, positive I2, shift 4 to the other side, so it's a negative 4. Let this equation number 3. We have 3 equations. We need to solve them. The question is that find I1 and I2. Then we need to replace I3 in terms of I1 and I2.
Mr.
Yes.
Why you've put in minus 5 I3 first?
Because I3 is the same direction as loop. In case of resistor, it's negative.
You said that you start
loop 2.
from...
I started from F.
Okay.
I go from equation 1, we can get I3. I3 equals I1 minus I2. So this is I3. Now, what we do? We take I3 here and substitute here. Now, take I3. Can you see? This is I3. Then substitute from equation 1 in equation 2. We write from equation 1 in equation 3. Then negative 5 open bracket. I3 is I1 minus I2 plus I2 equals a negative 4. Now simplify more. Distribute negative 5 over the bracket. Negative 5 times I1, it's a negative 5 I1. Negative times a negative positive, 5 I3, 5 I2 plus I2 plus I2, all equal to 0. It's okay? Again, negative 5 times I1 negative 5 I1. Negative 5 times negative I2, it's positive 5 I2 plus I2 equals 0. Okay, simplify. So it's negative 5 I1. Positive 5 plus 1, positive 6. So plus 6 I2 equals what? Oh, not 0, equals negative 4. This is not 0. Okay, it's negative 4. Okay, it's negative 4. Then the answer here is negative. This equation, what? This equation number. This equation has two unknowns, I1 and I2. And also equation 2 has the two unknowns, I1 and I2. Put them down each other. Then I1 plus I2 equals 2. That was equation 2. Now solve the two simultaneous equation by using the calculator. How? Follow me, please. You have the calculator FX95 and it is allowed in grade 12 exam. Then we go to the calculator and write mod. Follow me, please. Mod 3, 1. Then you will get two simultaneous equations. Now, write the answer in order. Negative 5. Start with me, please. Negative 5, right? Negative 5 equal. Negative 5 equal. And then 6 equal. Then negative 4 equal. And then if there is no number, it means 1. 1 equal. Then again, 1 equal. Then 2 equal. Then write equal again. You will get x equals 16 over 11. X is the first variable, which is I1. Then I1 equals 16 over 11. You can write this as decimal, two decimal places. So it's approximately 1.45 ampere. Write or press equal again. This is y. Y, it is the second variable, I2. It's 6 over 11. Press comma. Approximately equals 0.55 ampere. Okay, guys? Do you understand this question? Of course, we start with junction. So this is junction here. And this is another junction. Look at the currents. I1. I1 starts from junction F. So this is I1. This is I1. Can you see? This is I1. End at junction C. I3 start at C and end at F. This is I3. I2 start from here. This is I2. This is I2. It depends on the given, by the way. This is I2. I2 end at junction C. Then in part A, we say at junction C. The sum of currents in equals out, as Kirchhoff's first law mentioned. The current in is I1. The current in also is I2. The current out is I3. Then we write the current in is I1 plus I2 equals I3. I1 is given. Then we write 0.9 plus I2 equals I3. Then this equation number 1. Okay? So this equation number 1. Now, what about the loop? Here, the electromotive force 1 is 20. Electromotive force 1 is 20. Then this is the best way of direction of loop 1. We put the direction of electron flow. See here. This is the electron flow. We start with corner. Let we start at A. Now we write loop 1.
Mister,
Yes,
I have a question. How do you state the direction of the loop?
very good question. Thank you. Look, Binti. In the circuit 1, or okay, the closed circuit 1, just we have one battery or one source, is it? One source of what? Of electromotive force, is it? This is 20. It's like this, okay? So this is negative and this positive. Then the source of current comes from this power supply. Then this is the direction. Okay, Binti? Now,
Yes, Mister.
again, this is another source. Can you see? It's E2. So this is the positive and this is the negative. Then it's better to take this as loop 2. It's okay? Now it's clear?
Yes, Mister. Thank you.
Very good. Now, loop 1. We start from this. We go in this direction. We have the current I1. It is the same direction as loop, so it is 1 negative because it's the resistor. So it's a negative 1 I1. The electron flows the same direction as loop 1, so it's positive, plus 20. The current is I1, and the resistor is 5, the same direction, so it's 1 negative. Negative 5 I1. Now, down, the current is I3, the same direction as loop, and the resistor is 10, so it's 1 negative. Negative 10 I3. The current is I1, the resistance is R3, the same direction, so it's 1 negative. Negative 2 I1. Take care, you have to concentrate. Equals 0. Now, we collect the like terms. Negative 1 I1, negative 5 I1, negative 6, negative 2, it's negative 8. Then it's negative 8 I1. Is it correct? So negative 1 I1, negative 5, negative 6, negative 2, it's negative 8 I1 plus 20 minus 10 I3 equals 0. I1 is given 0.9, then negative 8 multiply 0.9 plus 20 minus 10 I3 equals 0. Use the calculator to calculate the answer. So, mode 1. Negative 8 multiply 0.9 plus 20. The answer is 12.8. Then 12.8 minus 10 I3 equals 0. Shift 12.8 to the other side. So negative 10 I3, it's negative 12.8. Cancel negative with negative, then I3 equals 12.8 divided by 10. So I3 is 1.28 ampere. Now, how can we get I2? Substitute from equation 1. 0.9 plus I2 equals 1.28. Then we can get I2. So it's 1.28 minus 0.9. Then the answer is 0.38 ampere. Then we write loop 2. Now, we start from this corner and go in this direction. The current is I2. It is in the same direction of the loop, so it is negative 1, negative 1, negative only one sign. So it's a negative 2 I2. Electromotive force is the same, so plus E2. The current is I2 and the resistor is 10. It's the same direction of loop, so it's one negative, negative 10 I2. The current is I3 and the resistor is 10, so negative 10 I3. The current is I2 and the resistor is 3, so only one negative, negative 3 I2. The answer is 0. Now we solve this equation. Collect the like terms, negative 2 I2 and negative 10. You can use the calculator. Negative 2 minus 10 I2 minus 3. The answer is negative 15. So negative 15 I2 plus E2 minus 10 I3 equals 0. Already we have I2 and I3, substitute. Then negative 15 multiply I2 0.38 plus E2 minus 10 multiply I3, which is 1.28 equals 0. Use your calculator. Negative 15 multiply 0.38 minus 10 multiply 1.28. The answer is negative 18.5. So negative 18.5 plus E2 equals 0. Shift negative 18.5 to the other side, then the value of E2 is positive 18.5 volt. Of course, we start with junction. It's the same way. This is junction and this is junction. Now, the current 2 ampere starts from this junction. We can say this is junction A and this is junction B. So the current 2 ampere start from junction B and end at A. I2 start from A. This is I2. Can you see? And the end at junction B. I1 start at A and the end at B. Now we apply Kirchhoff's first law. We write at junction A. The sum of currents in equals out. The current in is 2 ampere. Out is I1 plus I2. I1 plus I2. This equation. Sorry. Now we go to the loop. Already the loop is given in the circuit. Just we put the direction of electron flow. We start from any corner of the loop 1. I start from this corner and then I go in this direction. The loop direction the same as electron flow, so it's positive 6. So we write loop 1, positive 6. And then the current is I1 and the resistor is 4. The current in the same direction of loop, then it's 1 negative. So negative 4 I1 plus. At the end, then the answer is 0. Shift 6 to the other side, negative 4 I1 equals negative 6. Divide by negative 4 both sides. So I1 equals 1.5 ampere. Substitute in equation 1. So from equation 1, 2 equals I1 1.5 plus I2. Shift 1.5 to the other side, it will be minus. Okay. 2 minus 1.5, then I2 equals 2 minus 1.5, which is 0.5 ampere. So this is the value of I1 and I2. What about part B? Follow me, please. We have 2 ways to solve part B. In part B, we use loop 2. Follow me. I put the direction of electron flow. I start from the corner. Let us we start from this corner. Now I go in this direction. Remember here, I1, the same direction as loop 2. Then it's one negative, negative 4 I1. Now, can you see here? I draw this with red to be clear. This is the direction of the loop. Can you see? This is the direction of the loop. But the current in the circuit I2, it is in opposite to the direction of the loop. Then opposite means negative. Then negative, and then the current is I2 and the resistor R. So it's a negative I2 multiply R. You understand why it's a double negative? Because the loop direction is opposite to the current direction. Now, again, this is the loop. 3 electromotive E is the same direction as the loop, so it's plus 3 equals 0. Now we solve this. Negative 4 I1, it's 1.5. Negative, negative, positive, I2 is 0.5 R plus 3 equals 0. Now we use the calculator to calculate the value. Negative 4 multiply 1.5 plus 3, the answer is negative 3. Then negative 3 plus 0.5 R equals 0. From this, we can get R, shift negative 3 to the other side. Of course, your answer must be positive. So 0.5 R equal positive 3, divided both sides by negative 0.5, divide by 0.5, then you can get R. Then R equals 3
6 ohm.
divided, yes, 3 divided by 0.5, which is 6 ohm. Very good. 6 ohm.
Mister,
Now, just a minute, Mike. Another way. We can use Ohm's law. V equals I times R. What is R? R equals V over I. What is V in that branch? We have here V in that branch. Can you see? V equals what? V equals 3. Then again, in that branch, can you see here? V equals what? Equals 3. And the current is what? Is I2. Then we can get R. So R equals V, which is 3, divided by I, which is I2. I2, we got it before. It is 0.5 equals 6. You can use anyway. And number 6, he said, show that the resistance of the network is 40. Now, look, these guys. In this branch, the resistors are connected in series. We add them. 40 plus 20, it is 60 ohms. Now, 60 and 40, they are connected in parallel. Then R of 60 and 40 equals 1 over 60 plus 1 over 40, all to the power negative. We use the calculator. Fraction 1 over 60 plus fraction 1 over 40, close the bracket, all power negative 1. The answer is 24. 24 ohms. Then we replace 60 and 40 by 24 ohms. 24 and 96, they are connected in series. Then 24 plus 96 equals 120. Then this branch is 120. Then R total, this is part A. Then R total, 60 and 120 are connected in parallel. Then it's 1 over 60 plus 1 over 120, all to the power negative. 1 over 60 plus fraction 1 over 120, load the bracket, all to the power negative 1. The answer exactly is 40. It said show that the resistance is 40. Finished. Now, part B, calculate the current in 60 ohm resistor. The voltage here is 6 volt because they are parallel. Also, the voltage here is 6 volt. Then it is 6 volt, the total voltage. So in part B, we can get the current by using Ohm's law. V equals IR. Then the current in the second branch, it is V, which is 6 volt, over R, which is 120. Then 6 divided by 120, it is 0.05 ampere. 0.05 ampere. Remember, this is the current here. 0.05 ampere. We can get the voltage around the 96. We use another color. So we can get the voltage here. Okay, let this is V1. Then V1, it's I multiply R1. I is 0.05, R is 96. So the answer in the calculator, multiply 96, which is 4.8. Then 4.8 volt. We can get the voltage here, V2. So V2 equals V total minus V1. V total is 6 volt. V1, it's 4.8. So we write 6 minus the answer. It's 1.2 volt. Now the current, now the voltage around the 60 ohm is 1.2 volt. And the resistance is 60. So we can get the current. So the current in 60 ohm resistor equal the voltage divided by R. The voltage is 1.2 because they are parallel connection. They have the same 60 and at 40. They have the same voltage 1.2 because they are connected in parallel. So it's 1.2 divided by the resistance divided by 60. 1.2 divided by 60. The answer is 0.02 ampere. If you need to check your answer, find the current, okay, in 40 ohm. So the current in 40 ohms equal the voltage, which is 1.2 divided by 40. So 1.2 divided by 40. So the answer is 0.03 ampere. If you add them, you will get the current here 0.05. Then our answer is correct. Okay? Now, he said in the electrical circuit shown, each cell has EMF 1.5 volt. Then this is 1.5 volt, this is 1.5 volt, and also this is 1.5 volt. Then the total voltage of this battery is 3 volt. This is positive, this negative. Then the current goes from the higher voltage to the lower voltage. Then the current in the circuit is clockwise. This is the current, okay? He said, state the direction of the current, it's clockwise. Is it clear? Clear? Because it's from higher voltage to lower voltage. Now, calculate the current I. He said, the reading of voltmeter is 1.0 volt and the resistance is 10. We apply Ohm's law. Then, in part B, the current, this is the current in the circuit, by the way. The current equals V divided by R. V, it is 1.0, not 3, not 1.5, because the voltmeter give us the current, the voltmeter give us the voltage around specific instrument, about the resistor. So it's 1.0, the voltage divided by 10. So it is 0.1 ampere. Okay? The current in the circuit now is 0.1 ampere. Calculate the resistance R. Now we apply Kirchhoff's second law. We start from this corner and go around the loop. Then it's 3 volt. And then here, it's negative I multiply 10 and then negative 1.5, and the current here is I, and the resistor is R, so it's a negative R multiply I equals 0. Now, already we have the current 0.1, so 3 minus 0.1 multiply 10 minus 1.5 minus 0.1 multiply R equals 0. Now, we use the calculator. 3 minus 0.1 multiplied by 10 minus 1.5. The answer is 0.5. Then 0.5 minus 0.1 R equals 0. Shift 0.5 to the other side. Negative, so it's a negative here. Negative 0.5. Divide by negative cancel, then R equals 0.5 divided by 0.1, which is 5. First step, we find R total for the whole circuit. Now, follow me step by step. Try to be faster. We find the total resistance of 6 and 6. They are in parallel connection. So 1 over 6 plus fraction 1 over 6. Close the bracket, all power negative 1. It is 3. Then we replace that 1 by 3 ohm. Down also we have parallel connection. 1 over 4 plus fraction 1 over 12. Close the bracket, all power negative 1. It's 3 ohms. Now we can get R total. This is the first step. R total. When we go in this, we find the 3 ohms. 3 ohm in series, so it's plus. Now, we can replace this all by 3 plus 3, 6 ohms. And this branch by what here? Can you see? 3 plus 2, it's 5 ohms. They are in parallel. Then it's 1 over 6 plus 1 over 5, all power negative. Now we calculate the answer. So 3 plus fraction 1 over 6 plus fraction 1 over 5. Close the bracket, all power negative 1. The answer is 63 over 11. 2 decimal places. It will be 5.73 ohms. We have the voltage and we have the current, the resistance. So we can get the current. Remember, we use Ohm's law or Sambusa law. Then the current in the circuit. This is the current from the circuit. This is I. So I equals V total over R total. This is the current from the battery. The voltage from the battery is 18 volt divided by the total resistance 5.73. Then we write 18 divided by the answer. It's 22 over 7, or in 3 decimal places, it's 2 decimal places, it's 3.14 ampere. Now this is the current. From this current, we can calculate the potential difference around this one. So this, we can say this is V1. V1 equals I multiply R1. I is the current from the battery, which is 3.14, multiply the resistance 3. The answer in the calculator, multiply by 3. The answer is, okay, 9.43 volt. We can get now the voltage around the whole this. This is V2. Then V2 is V total minus V1. V total is 18 volt. We take away 9.43 to resistor 3. Then 18 minus the answer. It's 8.57. 8.57 volt. Okay, now we have the voltage. The voltage V2. And also we have the total resistance. 3 plus 2, it's 5. Then we can get I1. What is I1? This is I1, guys. It's okay. This is I1. I1, it's V over R. What is V? We calculated. It's 8.57. What is R? It's R total. 3 plus 2, it's 5. Divided by 5. So the answer is 1.71 ampere. We can get now the voltage here. Let this V3 equals I times R. I is 1.71 multiply R, which is 2. So we can get V3. So this multiplied by 2. It's 3.43 volt. Now we can get the voltage here around this branch, which is V, okay, we can say V4 here for the parallel circuit. Because the question is that find the current in 12 ohm. We need the voltage. Then V4 equals V2 minus V3. V2, it's 8.57 minus V3 is 3.43. So 8.57 minus the answer. So it's a 5.14 volt. Now the voltage around 12 ohm is 5.14 and the resistance is 12. By using Ohm's law, we can get the current now in 12 ohm resistor. The current, it's V over R. V, it is the same voltage because they are parallel, which is 5.14, and the resistance is 12. So 5 divided by 12. So the answer is 0.40, okay? 0.43 ampere. So it is 0.43 ampere. This is the answer, okay? I said yesterday, how can you differentiate between the parallel connection and series connection? Same current series, different current parallel. Here we have, this is the current is the same. Then 3, 4, and 3 are connected in series. We add them up. So 3 plus 4 plus 3, it's 10. Then we replace all of this by 10 ohms. 10 ohms and 10 ohms are connected in parallel. Then we can get R total. This is R total 1. So it's 1 over 10 plus 1 over 10 all to the power -1. Fraction 1 over 10 plus fraction 1 over 10 all to the power -1. The answer is 5 ohm. Then we replace all of these by 5. Can you see here? Then we replace that by 5 ohms. 5 ohms, 3 plus 2, then the total 5 plus 3 plus 2, it will be 10 ohms. Then that branch 3, so 3 plus 5 plus 2, it is again 10 ohms. 10 ohms and here 10 ohms, then it's 5 ohm. Then we can replace all of them by this. Then the circuit reduced to this. This is here, 5 ohms, and the total is 5 ohms, and then down it's 4 ohms. And here, this is the power supply, 28. Then R total of the circuit is 5 plus 5 plus 4 because they are series. It's 14 ohms. This is the first part. Second, we need the power dissipated by the circuit. The power, we use the voltage. Here, the power, this is part A. Part B, the power equals V squared over R because we have V, it's 28 squared, and we have the total resistance 4. Then fraction, 28 squared divided by 14, it's 56 watt. Last part, We say find the current in 5 ohm. We need the current from the circuit. Here we have the total resistance. Okay? So we can get the current equals the total voltage over the total resistance. The total voltage is 28 and the resistance is 14. 28 divided by 14 equals 2